Hello friends, we are once again meeting for yet a SPECOM version relay SPAJ 140C of ABB make, because we want to discuss different facilities provided in the relay. The facilities provided are in the different switch groups. The first switch group was switch group function, in which there were two, SGF1 and SGF2, in which there were different characteristics of relays which can be built up, and in another group SGF2 you can uh, rather make the start indicator self reset or hand reset. Then we went to switch group SGB, that is switch group blocking, which was a very important switch group in which you can do reverse interlocking, you can do temporary blocking of the relay. That means if the downstream relay locates the fault, if downstream relay senses the fault, you can send the blocking signal to the upstream relay so that it does not operate, because it is not required to operate. The downstream relay has sensed. Therefore, the main advantage of this reverse interlocking or blocking feature is that the discriminating time interval between two successive relays, which we are usually keeping, or which we were usually keeping as 0.25 second or 250 millisecond in old uh, electromagnetic or static relays, we can reduce to as low as 40 millisecond, that is 0.04 second in this relay, if we use this facility of temporary blocking, which is provided by SGB oblique 1, 2, 3 and 4 for I greater than, I double greater than, I0 greater than and I0 double greater than. Then SGB 5 was giving a very important function, that is double setting groups, two setting groups. You see, you can have two flux settings, two same time settings, two high set settings, two different characteristics, everything double, everything twice. Yes, because the power system will be changing. At different times the power system is changing. In different seasons the system is changing. If some line trips, the power system changes. If some generator trips, the power system is changing. So when the system changes, when the normal power flow and the abnormal, that is fault power flow changes, your relay has to adapt with that change. And that was just not possible with the old relays, because there was only single setting group available. Here in this relay there are two groups available, and as I was telling, there are as many as 6 groups available in the recent most numerical relays. So that was the facility in SGB 5. SGB 6 and 7 were latching, that is hand resetting of the trip signal. So these were the facilities in SGB, that is switch group blocking. Now we are going to talk about the last switch group, SGR, that is switch group relay configuration. In this switch group there are three switch groups, SGR1, SGR2 and SGR3. We are going to talk about two out of the three, SGR1 and SGR2. SGR3 we will reserve for the next tutorial, which will end with the talk on SPAJ. So what are the facilities provided in SGR1 and SGR2, that we will try to see in this particular tutorial class. Yes, you see, we have seen that the protection stage starts when the current exceeds the preset setting. Say for I greater than, if I set the current at 1 ampere, if current crosses 1 ampere, the relay starts and it is going to operate after a certain time. Right. Uh, Now that start signal is available. Right. So that start signal can be used for reverse interlocking, as we have seen. That means you can block the upstream relay. That was one important application of start signal. Similarly, another important application is that if you want to indicate that start signal somewhere else, not on the relay panel, but somewhere in the control room, somewhere in engineer's cabin, right? If you want to indicate that, that indication is possible because start output is a dry contact, and that dry contact you can use to indicate the starting of the relay. Somebody has, is using the relay, and that particular relay has started. It has started sensing the fault I greater than, similarly I double greater than, similarly I zero greater than. So that start function indication at remote place is possible using SGR1, right? So this is the facility available. So how this facility is made available? If SGR1 oblique 1 is equal to 1, then I greater than stage is routed to SS1. SS1 is a relay. It's a relay in the main relay SPAJ, small relay. And that SS1 has one contact, and that contact can be used to indicate the starting at remote place, right? So SGR11 will start and it will route the signal to SS1. But if you make it 0, then the signal will not be routed to SS1, means start indication is not available if you so want. Similarly, SGR1 oblique 3 is for I double greater than, routed to same SS1. SGR130 means no route is available. SGR135 is for I0 greater than, to be routed to SS1. SGR1 oblique 7 is for I0 double greater than signal to be routed to SS1, and thereby using the dry contact to be indicated somewhere at remote place, right? So this is the possibility. Figure wise, I can show it like this. SGR1 is equal to 1 means if that switch is made on, it's a soft switch. It's not a hard switch. You have to make it on through computer, right? So either through computer or using the step and program push button provided on the relay panel. By any way you can do it. But if you make SGR1 oblique 1 equal to 1, that is you make that switch on, then SS1 is, that signal will reach to SS1, and that SS1 has two contacts, 70 and 71 dry contacts, which you can use to indicate some lamp or alarm or whatever you want at the remote end, in the engineer's cabin, in the control room, wherever you want to. Similarly, SGR13 for I double greater than, SGR15 for I0 greater than, SGR17 for I0 double greater than. These facilities are there for SGR1, right? SGR1, we were talking about SGR1, 1, 1, 3, 1, 5, and 1, 7. Yet SGR1 oblique 2, 1 oblique 4, 1 oblique 6, 1 oblique 8 are remnant. So that SGR1 oblique 2 is for operate. It is not for start now. It is for operate. When the relay operates, the signal is routed to TS2. TS2 is the main trip relay. TS2 is the main trip relay. That is, the main circuit breaker will trip if SGR12. That means if I greater than has crossed the limit and relay is operated, meaning to say otherwise, your setting is 1 ampere. If the current has crossed 1 ampere, and then say if your time of operation is 1 second, after 1 second the relay operates, and then that operate signal is routed to TS2. That means the main circuit breaker trips. Now you would obviously ask the question that why at all you would not want that signal to reach? Why that switch is provided? If I make SGR1 2 equal to 0, then that signal will not reach to trip. That means main circuit breaker will not trip. Now, one may easily ask a question that why do you not want to trip? You would want to trip when the fault has occurred, when the time has passed. You see, to avoid the damage to the system, the faulty part has to be isolated. But no, when you want to test the relay, when you are testing a relay at that time, you just want to know that yes, relay has crossed 1 ampere, 1 second has passed, relay has operated correctly. Therefore, you tested that relay has operated correctly. But when you are testing, you do not want the main breaker to trip. Because you see, when you are testing, you will be taking some 10 readings. For inverse characteristic, you will make PSM equal to 2, PSM equal to 4, PSM equal to 6, PSM equal to 8. You will take many readings. You will take 15 readings, 20 readings. 20 times the breaker will trip. So, the consumer will be under difficulty. Consumer will be under discomfort. Right? Nobody would want that the breaker trips on and off. Some industry is working, some process is going on, and then process is interrupted every now and then he is under heavy loss. You see, if the breaker trips like that, and you know that there is no fault, you are just testing. So when you are testing, you will make SGR1 2 equal to 0, so that the operate signal does not reach final tripping. Right. Similarly, SGR1 4 is for I double greater than. SGR1 6 is for 0 greater than. SGR1 8 is for I 0 double greater than, to make it to reach to final trip signal or not. Why not? You would not want to make it to reach if you are testing a relay, right? So that is for SGR1. That was for group SGR1, switch group relay configuration 1. Now switch group relay configuration 2, another switch group. That is a typical function. SGR21 to 28. You see, that what does it do? It makes the signal to reach to two signal relays, SS2 and SS3. Two signal relays are there. You see, so often you would want that the relay is in one place, right? It is in the relay panel. But in the cabin of the engineer in charge, you would want that he would want to know whether the relay is operated or not. Hmm? Somewhere else, somewhere at a remote place, somebody wants to know whether the relay is operated. So SGR2 1 equal to 1, then I greater than operate stage is routed to SS2. That means when the relay crosses the plug setting and when the relay operates, the signal will go there. It is a dry contact. You can sound an alarm also, you can light a lamp also, you can do whatever you like. But the person will come to know that the relay has crossed the I greater than and it has operated. If you do not want that, then make 2 1 equal to 0. Similarly, 2 2 equal to 1 is for same I greater than stage for SS3. That is, you want to make it to reach to some another remote place. One is the engineer in charge, another is the control room. You see, in power station, you will find that there are many places. In power plant, there is one main control room, which is controlling the generator. But then there is another place, that is 6.6 kV control cubicle. So at 6.6 kV control cubicle, it's a different place. It's a different location. There you would want some signal to reach. Then you would want the signal to reach to engineer's cabin. So you can make the signal to reach to different locations. So SS3 is another signal relay, right? And the dry contact, you can make it to reach for I greater than, same. SGR2 3 is for I double greater than to reach to SS2, I double greater than for SGR2 4 equal to 1, I double greater than will reach to SS3. That is another signal location. SGR2 4 0, then it will not reach. SGR2 5 equal to 1, I0 greater than will reach to SS2. One signal location. I0 greater than some value, plug setting value. Huh? To 6, it will reach to SS3, another signal location. To 6 is I0 greater than for not allowing to reach to SS3. S0 to 7 equal to 1. I0 double greater than stage 2 to be routed to SS2. To 8, I0 double greater than stage to be routed to SS3, another location. So these are signal locations, signal relays. So start function and signal function. These two important functions are provided by. These things were not available in older versions, in older relays. Here, you can announce the relay operation, announce the start of the relay at multiple locations. And that facility the relay is providing. That facility the relay is providing. SCR21 is for SS2, SGR2 3 is for SS2, SGR2 5 is for SS2, SGR2 7. If you make them 1, then it will go to one location, but SGR2 2, it will go to, I mean, another SS3, second location, right? So, like that, I greater than, I double greater than, I0 greater than, and I0 double greater than can be made to reach to different locations, right? That is possible. In our laboratory, what we did, we do not have different locations. No doubt we can do. We can make the relay start indication or relay operate indication to reach to the teacher, to the cabin of teacher in charge, or to the cabin of head of the department of electrical engineering. That we can do. I mean, it is not impossible to be done. But then you need those long wires to be run. Instead, what we have done, that we have provided the signals. The signals means the visual indication on the same panel. And for providing on the same panel, we have wired this circuitry. We have wired this. SS1, 77 and 78 is start. So that start lamp will come. So you will come to know that the relay has started. And for operate signal SS2 and SS3, uh, the lamp will come. But you see, they are self-reset. Contact cells 8081 SS2 and 6869 SS3 are self-reset. So lamp will go away once the relay resets. If you do not want that, what we do is by 8081, once the auxiliary relay is energized X1, then it is latched by its own contact. And I have got a NC push button PB1. I have to push that NC push button PB1 to reset the relay. Otherwise, the relay will not be reset. Right. So the lamp indication will keep on indicating the lamp unless you reset, unless you hand reset. So PB1 and PB2 are shown normally open. It's a typo, it's a mistake. It has to be NC. They have to be NC contacts, right? So it's a usual practice. They have to be NC contacts. Then only you will be able to latch, right? So this this facility you can wire in laboratory, right? And we have at Birla Vishwakarma Mahavidyalaya Engineering College at Vallabh Vidyanagar a very well-known place. It's a city where Vidya is given, and it is near Anand. Anand is a very well-known city all throughout world because it's a milk city. It is known as a milk city. Mr. V. Kurian established the dairy business there, right? So it's a very well-known place. That Anand and Vidyanagar are in Gujarat state in India, right? So in that engineering college, we we rigged up this facility. We we showed this facility to the students. We are simulating the things and we are showing to the students the facilities too of the relays so that when they go to the field they do not find it new. And many engineering colleges in Gujarat state afterwards copied this arrangement of laboratory. I mean, there is nothing wrong in copying. I don't deny. I mean, I don't make a negative statement. It's good that they have copied. I would want that many engineering colleges should copy, right? In PDPU also they have done in their own way. Pandit Dindayal Petroleum University. Dr. Vivek Pandya has tried his best to do it yet better than what BVM has done, right? So it's good that people do it, and that's the reason why I'm rather uh, preparing these videos that people in one way or the other they design the circuitries, they show to the students because what we are doing till date we are yet showing that old disk type relay. I was telling to you that at Vallabh Vidyanagar at BVM, a professor from IISc Bangalore, Indian Institute of Science Bangalore, a very well-known IIT in India, he had come to review the syllabi because BVM became uh, because they received the grant from World Bank of 10 crores of rupees. So BVM had to become self-sufficient. They have to, they cannot depend on any other university. They have to, uh, they are now they're of their own. They have their own syllabus. So they were to show that syllabus to someone. So they showed that syllabus to uh, Mr. Tukaram, who is the professor at IISc Bangalore. I don't know whether he has retired now or not, but at that time he was there. And he saw the syllabus of electrical measurement 2 of energy meter, and he read the sentence that creep of the energy meter. You see, in old days the analog meters were creeping. Why they were creeping? Because it was analog. Current coil is there, voltage coil is there. Current is not passing through current coil. I am not using any power, but voltage is obviously there. So because of the voltage, the disc keeps on moving very slowly, however, but it keeps on moving. And because it keeps on moving, it registers. And because it registers, the registering mechanism will show money. So the meter reader will come and charge money. So the client will take an objection that I was at America, I was at USA, I was at Canada for last 10 years. And after 10 years, when I come, I am seeing a bill of some 500 rupees or 1000 rupees or 8000 rupees. How? When I'm not there, why the bill is there? Because the meter is creeping, because the disk is creeping. And therefore, you see, in the energy meters, the anti-creep arrangement has to be provided. I was there for 3 years in analog energy meter manufacturing factory, so I know everything. So anti-creep arrangement is required to be provided so that the meter does not creep. But all this was required to be learnt. All these were required to be taught. All these were required to be kept in syllabus because analog meters are there. So Mr. Tukaram asked a very basic question to head of the department that yes, Mr. Rasesh, you go to your house and see whether your disk creeps. आपके मीटर में डिस्क है, there is no disk in the meter, how will it creep? But yet we are rather teaching that old relay, disk type relay. It has got a coil and 7 tappings are taken out, 50 to 200% in 7 equal steps. And then How we are controlling is the time multiplier setting. Time multiplier setting is controlled by a backstop. You can bring the backstop near or, but that backstop is not there, my friend, now. That disk is not there. Forget about it. Don't teach. Teach new things because new things have come. So I would wish that everybody, everybody should teach new things. New things have come. Not only this relay has also become out of date. Yet better relays have come in the market. You teach better relays. The teachers should teach better relays. The student should learn better relays. Students should learn modern technology because they are going to work in modern technology. When they go to the field, they are going to work in the modern technology. This figure we had seen in the last tutorial also for showing the things, for showing the functions of SGR1, SGR2, etc. You have to have some uh, circuitry, power circuitry and control circuitry. So that power and control circuitry I had explained in last tutorial. I will not repeat. So all these things I had explained. So I will not repeat. And hence I I come to an end of this tutorial talking about SGR1 and SGR2 in the relay type SPAJ 140C of ABB make. Uh, However, this relay has become out of date. I yet feel that that relay was very important. It is teaching very good things. And if you learn that relay, the newer version you will be able to understand yet in a better way. Therefore, I really am really very much thankful to ABB. Uh, I have to be thankful to ABB, not only because ABB is a company, but in ABB Baroda and in ABB Bangalore also, the engineers who are there, some 20 to 25% of engineers are my students. So I come to know whatever is happening there latest in the factory. I come to know the next day, the next moment. Therefore, I thank all my student friends. All my student friends are loving me very much because I taught them with same love and they are now reflecting their love to me. So I am thankful to ABB. I am thankful to all my student friends. If I start reminding, I can start from 1986, from where I started teaching the students to 2012 when I retired. And now somebody comes and tells to me that, sir, I'm thankful to you because uh, you are a reason uh, for me to get a good job. I ask him, when did you graduate? He says that I graduated in 2021 or 2022. I'm sorry, not 2022 is yet to come, but 2021 or 2019 or 2018. He says that, sir, you had retired, but you were coming to deliver the expert talks in our institute. And our teacher who teaches us takes your name every day. In every lecture, your name comes 10 times. Therefore, you see, right from 1986 to 2021, all loving students are who are there now at a very good senior post. They are giving me the inputs. Therefore, I am thankful to them. So, with all that thanks note, I I read a sentence. I like to read one good sentence, right? Which will teach us a lesson. Life is not a problem. To look at it as a problem is to take a wrong step. We are thinking that life is a problem. Every time and there, dukh hai. We are getting unhappiness. We are getting some trouble. Huh? And we feel that at every point there is a problem. No, there is not a problem. It is a mystery to be lived. Life is a mystery. एक एक puzzle है. Life is a puzzle, and you have to solve that puzzle. You have to enjoy solving that puzzle. And once you solve that, you will like it very much. You will enjoy it very much. That yes, you could find out the problem, the solution to the problem, and you yourself has found out. So you have to solve the puzzle. You have to live in that mystery. You have to love the mystery, and you have to experience that mystery. Not to take it as a problem, not to take it negatively, take it positively. Therefore, my friends, with that, I end my session with a note to remember adapt me. Hmm? Don't forget adapt me. I say every now and then that don't forget this adapt me, because adapt me is teaching you. And my friends, now adapt me is teaching you at no cost. I am giving these videos in YouTube at no cost. You can go through these videos, learn things, and teachers can rather rig up these experiments in the laboratory. Hmm? I'm not charging anything. Nobody is charging. Adapt me is not charging. Adapt me is for your service. It is for your selfless service. So don't forget adapt me, because the person who serves you, person who gives you knowledge, the person who rather who is for you without any cost, you should not forget. Huh? You should not forget him till the end of your life. So please remember adapt me. Thank you so much. Good day. Don't forget adapt me and appraise. Thank you.